Good scientific morning to you, fellow scientists. My name's Ryan Krueger, and today my colleague Peter Leutz and I are going to take you deep into science. So deep that the pressure in this biome would implode us. The deep sea. We're going to venture down more than 4,000 meters below sea level to see the mysterious and wonder that lives below. Come with me as we go off the deep end.
Oceans make up approximately 70% of the planet and takes up 90% of habitable space. Oceans are also home to around 65% of all life on Earth. The oceans are split into different zones based on depth.
The epipelagic and upper mesopelagic zones, or the top two, are the zones most people primarily think of when thinking of the ocean. That is where most life is and the most diversity in fish. We are focusing on the zones further than that. The bottom portion of the mesopelagic, the twilight zone, and even deeper. The mesopelagic zone's climate can range from 20 degrees Celsius to 4 degrees Celsius as you go deeper to the boundary of 1,000 meters below sea level. Eyes of animals in this zone are often quite large to collect any available light as sunlight begins to wane in this zone. The next zone, the bathypelagic zone, which is 1,000 to 4,000 meters below sea level, receives no light. Because of this, the temperature is a cool 5 to 6 degrees Celsius. Brr. Bioluminescence is a key factor for organisms to lure prey in and to see in this zone. The lack of light means that this zone isn't exactly lit, but it's better than staying at home on a Friday night if you catch my ocean drift. Ha ha ha. Lastly, the abyssopelagic zone is from 4,000 to 6,000 meters below sea level. As you go deeper in the ocean, the pressure increases, and once you reach the abyssopelagic zone, it can range from 200 to 600 atmospheres. Keep in mind that on land, it is only 1 atmosphere. This zone has a high salinity, as salt deposits on the bottom of the ocean floor, and waters can be upwards of 30 psu. Many organisms in this zone have evolved, because of these conditions, to have their eyes on the top of their head, as much of their food is above them. In addition, many organisms that exist towards the bottom of the sea, because there is no light, have a keen sense of smell that helps them find their food.
You got that right, Peter. Also, the biodiversity in these areas is plentiful thanks to producers such as phytoplankton. As you go further down, pressure increases and so does salinity. This biome may seem nice, but it's low-key really salty. Organisms exist at particular depth levels based on how well suited they are to survival. Some animals migrate vertically in order to feed upon the abundant life in the bright zone above them. A basic food web for this biome looks something like this. However, because there are no true boundaries in the ocean, you eat what comes to you. Both food chains are interconnected, even though they occur in different ocean zones, because organisms travel all throughout the ocean. A key factor deep in this region is that many microorganisms in the ocean use chemosynthesis to produce biomass from single carbon molecules. Chemosynthesis is a biological conversion of one or more carbon-containing molecules and nutrients into organic matter using the oxidation of inorganic compounds. This allows for food chains to develop as they become the producers. Most of the organisms in this biome lure their prey in, or simply wait for the prey to come to them. Some predators lure their prey with bioluminescent barbels that look like small animals. Bioluminescence is key for survival as no light reaches this part of the ocean. Here it is in action. We are about 4,000 meters below sea level, and as you can see there is some type of light in the ocean. That light is bioluminescence. However, these fish don't realize. Here they are inspecting the light. They don't know what it is, as they aren't usually from this biome, so they don't know much about what's going on. They're still inspecting it, and one decides to touch it. What's gonna happen here? And there it is. The predator using bioluminescence. Oh my word! And the chase begins. They're quickly swimming away, except their prey's coming close up to them. It's going to be a close one this time for the fish. Oh, and they just ducked down out of the way.
Although deep in the depths of the ocean, the quantity of mesopelagic life is large enough to play a significant role in global carbon cycling. As the fish participate in the food chain, they acquire carbon rendered from carbon dioxide absorbed by surface waters. Upon death, they transport that carbon into the sea bottom or back upon coastal shores.
And now for some of the most noticeable organisms from each zone. In the mesopelagic zone, squid, cuttlefish, prickly shark, and wolf eels. In the bathypelagic, we find comb jellies, vampire squid, my favorite, the barrel eye, and the notorious anglerfish. And finally, in the abyssopelagic, we have the Dumbo octopus, cookie cutter shark, and tube worms.